Good day, everyone. My topic is a continuation discussion on Theorem 5.2, Disjoint Cycles Commute. According to this theorem, if the pair of cycles alpha equals A1 through AM and beta equals B1 through Bn have no entries in common, then alpha beta is equal to beta alpha. The proof of this theorem has already been discussed by Ms. Agan. Now, let's try to look into some examples showing that disjoint cycles commute. Let us consider a set S with elements 1 through 6. For example number 1, suppose we have our alpha equals 1, 2, 5 and beta equals 3, 4. Since these are permutations of S6, we can write our alpha equals, for the first row, 1 through 6, and for the second row, from the given values of alpha, 1 maps to 2, 2 maps to 5, and then 3 and 4 map themselves, 5 maps back to 1, and 6 maps itself. For beta, we have here the same with alpha 1 through 6, and from the given, 1 and 2 map themselves, 3 maps to 4, and then 4 maps back to 3, 5 and 6 map themselves. Therefore, alpha beta is equal to the following. We have here the two array form. Take note that in multiplying cycles, we start from right to left. So in here, let us start with 1. So 1 maps to 1 and 1 maps to 2. So we have here 2. Then 2 maps to 2, 2 maps to 5. That's why we have 5. 3 maps to 4 and 4 maps to itself. That's why we have 4. 4 maps to 3 and then 3 maps itself. We have there 3 and then 5 maps to itself and 5 there maps to 1 and then 6 maps itself. So the product of alpha and beta is equal to the array 1, 2, 3, 4, 5, 6, 2, 5, 4, 3, 1, and 6. Let us do the same for beta alpha. So for beta alpha, we have here the arrays 1 through 6, 1, 2, 4, 3, 5, and 6 multiplied with 1 through 6 and 2, 5, 3, 4, 1, and 6. The same procedure with the alpha beta. Let us start multiplying from right to left. So we have here 1 maps to 2, 2 maps to 2, that's why we have 2, 2 maps to 5, and then 5 maps itself. We have here 5, 3 maps to itself, and then 3 here maps to 4, that's why we have 4, 4 maps itself, and then 4 here maps to 3, that's why we have 3, 5 maps to 1, and then 1 here maps to itself, so we have here 1, and then 6 maps itself. As you can see, alpha beta is equal to beta alpha. If we express this as a product of disjoint cycles, it would look like this. So for the alpha beta, we have here, so let's start with 1. 1 maps to 2, and then 2 maps to 5, and then 5 maps back to 1, so we can close the cycle. Next, let us have 3. So 3 here maps to 4, and then 4 maps back to 3, so we can close the cycle. And next, 6 maps itself. Usually, single cycles are not written anymore. Therefore, alpha beta can also be written as 1, 2, 5, 3, 4. And that is the same with beta alpha since they have the same values. So obviously, alpha beta is equal to beta alpha. Let us have another example. Still using the set S with elements 1 through 6. Suppose we have now alpha equals 1, 4, 3 and beta equals 2, 5. In our notation, we can have our alpha be equal to this array 1 through 6, 4, 2, 1, 3, 5, and 6, and our beta is equal to 1 through 6, 1, 5, 3, 4, 2, and 6. So in multiplying alpha beta, we can have the same with the previous example. Let us start from right to left. So we have here 1 maps to 1 and 1 maps to 4. That's why we have 4. 2 maps to 5, then 5 maps to 5, so we have here 5. 3 maps itself, and then 3 here maps to 1, that's why we have 1. 4 maps itself, and then 4 here maps to 3, so we have 3. Next, 5 maps to 2, and then 2 here maps itself, we have here 2. And then lastly, 6 maps itself. So we have here the value of our alpha beta. The same procedure with beta alpha, we can have our beta alpha equals the arrays 1, 2, 3, 4, 5, 6, 1, 5, 3, 4, 2, and 6 multiplied to the cycle 1, 2, 3, 4, 5, 6, 4, 2, 1, 3, 5, and 6. Starting from right to left, we can have 1 maps to 4, then 4 maps to 4 here, so we have here 4. 2 maps itself, then 2 here maps to 5, we have 5. 3 maps to 1, then 1 maps to itself, so we have here 1. 4 maps to 3, and then 3 here maps itself, so we have 3. Next, 5 maps itself, and 5 here maps to 2, so we have here 2. And then 6 maps itself. Comparing alpha beta and beta alpha, we still got the same answer. As the theorem states, disjoint cycles commute. Now, in demonstrating how to multiply cycles, we have shown it through an array form. But what if we have these disjoint cycles? 1, 3, 2, 7, 4, 5, 6, 8 multiplied to the cycles 1, 2, 3, 7, 6, 4, 8, and 5. It would be enormous to express this in an array form. So we can just make use of this cycle notation to find its product. It can be observed that these cycles are permutations of S8. To find the product, let us start with 1 from right to left. So we have here 1 maps to 2, and then 2 maps to 7. That's why we have 7. Next, 7 maps back to 1, and then 1 maps to 3, so we have here 3. Next, 3 maps to 7, then 7 maps to 2, that's why we have here 2. Next, 2 maps to 3, then 3 here maps back to 1, so we can close the cycle. Next, let us have 4. So 4 maps to 8, and then 8 maps itself. Next, 8 maps to 6, and then 6 maps back to 4, so we can close the cycle. Next, let us have 5. 5 maps to 6, and then next, let us have 5. So 5 maps itself on the right side, and on the left side, 5 maps to 6. Therefore, the product of the cycle is equal to 1, 7, 3, 2, 4, 8, 5, and 6. That would be all. Thank you.